In this example, we use a property flex to split the container. For example, the first one, we have two example code here, and this is the example. So it has a view and a text, but it doesn't tell how to split the container. If it doesn't tell us how to split container, then each example takes 50% of each. So this A takes 50%, B takes 50%. But we can also split the container by specifying flex2. So flex2 means for the whole container, this D takes 2 to 1. So altogether, this is the 33 and 33. Altogether, it's 66 plus 33. That's 1. Because right here we say flex2, it takes 2 shares. And this one is only 1 share. That's why this one takes a lot of space. And you also can say flex3. Right here means one element container, just one element. But this element takes size 3 times of this example. So we have a 25 and this is 75. That's how we split the container by using flex. Now if I change this one to 5, you see what happened here. Now you can see there's more space added to this container. This time we split the container by row. So I have 2 columns here. How do we change the direction? The default direction is by column, so you split the container up in the middle. But now we're trying to split container vertically, not horizontally. So how do we change the direction that I want to split container by vertical direction? All we do is we still do the same thing here. See, there's the flex 2, it's the flex 3, but right here in flex container we say flex direction row. Once we change to row, it split the container by vertical direction. That's the row. The default is column. That's horizontal direction. That's how we split. That's how we change the split direction using flex direction property here. Flex container, added to flex container. So that's pretty much the whole code here. So flex container is called, and also notice here in container we say flex 1, means it's just a whole one unit. Whole container is 1 unit, 1. And then in the flex container, when we count right here, flex container in each view. In each view, we call flex container, and we tell that we want to split vertically. So flex direction row. JustifyContent defines how space is distributed between and around flex item along the primary axis of container. 5 options. Center causes the children to be centered within parent container. Free space is distributed on both sides of the clustered group of children. Flex start groups the components at the beginning of the flex column or row, depending on what value is assigned to flex direction. Flex start is the default value for JustifyContent. Flex end acts in the opposite manner. It groups items together at the end of the container. Space around attempts to just evenly distribute space around each element. So this if you want to add a flex box to allocate the same amount of space on each side of element, you get a space, element, space, space, element, space. In both cases, amount of the white space is the same, but in later, the space between element is greater. Space between doesn't apply spacing at the start or end of container. The space between any 2 consecutive elements is the same as the space between any other two consecutive element. So let's look at this example here. Right here, we're trying to create something like this. So here's a container. Now inside we have two elements, two examples, but here we specify center. So you can see JustifyContent center. Both those two elements example are at the center of the whole block. Now JustifyContent start. So you can see there's two elements right here. So say start, that's on top, and that's on the bottom of the square. Around we have space here, so space, element, space, space, element, space. So altogether we have 1 space, 2 space, 3 space, and 4 space. Because we say around means there's space here and here, but there's also space here and here. That's why we get this layout. Space between means we have the first element on top, and here's a space, and the last element is the bottom. That's space between. These are the rest of the code. Align items defines how to align children along the secondary axis of their container. This property is declared on the parent view and affects its flex children just as flex direction did. 4 values: stretch, center, flex start, flex end. Stretch is the default value. Now let's look at this example here. So right here we call flex container and align item center, align item flex start, align item flex end. Now let's look at a flex container code here. So we scroll down here. You see this is the container flex 1. That's whole unit is flex 1. And flex container with a size dark gray color, light gray. Example, flex 1 align item center, justify content center. That's the from each example. Now let's look at that's how we can see it. By default we have everything in the middle right here, and it's split half and half. But if you look at here, you can see that align item center. Now if I take it off, let me take it off here. I'm going to take it off, remove it. And now if I save the document here, you can see this is what it looks like at the beginning. So the default is stretch. So that's how it looks like, this default value. But if I put this code back here saying align item center, see the change here. See, that's what we get here. Centered and become smaller. And this is the flex start. This is the flex end to push it to the end. And meanwhile we just split each flex. So like this one here is a 50 by 50 by default, and this is the flex 2, and this is the flex 3. So that's how this is the 1, 2, 3. So this is the 2. So this is the 3, 3 to 1. This is the 2 to 1. This is the 1 to 1. Align self gives you the ability to override whatever alignment was set on the parent container. So a child object can be aligned independently of its peers. There are values we can use: auto, stretch, center, flex start, flex end. The default is auto. It takes the value from parent containers, aligns item. The remaining property affect the layout in the same way as their corresponding properties on align item. So in this example here, we can see we have align, auto, stretch, center, flex start, flex end. Here auto means this example inherits from the parent flex container. Now let's look at the code down below here. We have container, flex container, example. Right here we have a line item center from the container. So this item, this align is inherited to here. So align auto. Because it's the flex container, it's in the parent container. Now if you look at the code we created here, this is the flex container. And right here we say flex container props style children. And that's the example. There's a view created here. In this view, it has example and align self props or auto. Means we either get it from parents, or if parents doesn't have any alignment value, then we set auto. So that's what the code for the view and also for the text in the example. So here's the example here. It says auto, and that's the same value we put it down here for the view in this example, auto, automatically. So we'll get this one here. And then the next one is a stretch. So stretch to go across the whole. And the center is here. Flex start is right here. Flex end. The last one is default. Flexwrap takes two values, no wrap and a wrap. Default is no wrap, meaning the item will flow off the screen if they don't fit. The items are clipped and the user cannot see them. To work around with this problem, we use a wrap value. So this is the no wrap. It's keep going. There's no enough space, but it's hidden right here. But it's okay because no wrap. Just keep going. So user only can see this part here. The rest of the part we don't see it. If it's a wrap, you can see we have 1, 2, 3, 4, 5 items here. But no wrap, we only see 4 and 3.5. With wrap, we can see all of them because if there's no enough space to show 3 and 4, it'll push to the next row. There's no wrap, and this is the wrap. Wrap is the default. Now let's see the example. So this one we have here. We have just no wrap. We have 1, 2, 3, 4, and this is the wrap. And we got this example here. Look at that. We have 1, 2, 3, 4, and the fourth is not completed. But if it's a wrap, we can see all of them. If there's not enough space for 4, the 4 is put down here. But here we don't see complete 4 here. So here's the code to do it. No wrap. It says flex wrap, no wrap. Here's wrap. So one's no wrap, one is wrap. No wrap, it's go out. So let me make it a little bigger. Let me change to 80. So you can see we only see part of the 4. Let me change to 90. Now you can see we have 1, 2, 3, and we only see 4 blocks here. But with wrap, we see all of them, and there's no enough space for 3 and 4. It pushed to the second row. So that's what will happen right here. This is the no wrap container, and this is the wrap container. You probably want to use a wrap container because that way user can see all the information.